Hey, this is Mark, and today I've got a Note 8 that is here because the complaint is that there's no power. It doesn't turn on, and when it sits on the charger, it pulls about 400 milliamps and just kind of stays there. Never charges up, never turns on. So what we're going to do is first connect it to a DC power supply. And I have my power supply hooked up through a Power Z dongle, which is kind of like a USB ammeter, and it allows me to give you guys a display on the screen up there in the top left of the voltage and current that is currently passing through it. So I'm going to turn that voltage down because I had it at 5 using it to charge something earlier. Now we're going to pull it down to right at 4.2. You can see it's consuming 1.3 milliamps right now, and that's just because I have a couple of different DC power supply cables hooked up through it, and that's they have like LED indicators on them, so that's what the LEDs are pulling. So essentially, when it says 0.001, that's the same as 0. Let's see when I connect power. Look at that. We immediately have a jump up to 3 amps. So this is definitely consuming a lot of current. Now I have already used the thermal cam to kind of narrow down the area that's getting hot, and it's this area. So I've clipped out some of this bracket so I can get in and take some measurements. And we'll go ahead and probe around a little. So whatever line that coil is on is shorted. That's okay. That's okay. That's okay. Short, short, short. So definitely we've found a shorted line, and what I will normally do is just remove whatever's getting hottest, and in this case the thermal cam said that really it's just this chip right here that's getting hot. So this is the SM5720. It is a chip that we find in like the S8, S8 Plus, S9, I believe also has it, S9 Plus, and the Note 8, and I think even the Note 7 also has it. So this is the chip that handles charging, and it also connects battery main to VCC main. So we'll go ahead and remove this chip and see if that relieves our short. And if it doesn't, then we'll say, what the hell, thermal camera, you lied to me, and start knocking off caps. All right, so got him off, and do we still have a short? Yes, we do. All right, so our thermal camera did lie to us, or perhaps the short is farther up underneath that shield and it just was not apparent. So what I'll do now, rather than just knocking off every cap that I can test here, I will inject voltage directly into the line and see what else, if anything, gets hot. There we go. Just want to get that wire soldered on really good. All right, so we will connect up our ground. And we do still have that 3 amp short, even stronger short now. It's still pulling the 3 amps, but it's pulling the voltage all the way down to 1.7, where it was around 3 point something before. So the lower your voltage goes, once you hit that current limit, that's an indicator of a stronger, thicker, lower resistance short. It's a short that allows even more current to pass through than what you're allowing, and that pulls the voltage down. So let's get the thermal cam back out and see if we can get an honest answer out of it this time. Now, I generally have a hard time getting a good picture to show up for this camera. Probably because I have that set to manual exposure. I'm going to set that to auto. Oh yeah, there we go. That works a lot better. That was the problem this whole time. Gotta use auto exposure. All right. So we're going to connect power. And the difficulty with doing this is that the wire naturally gets hot. So it's a little hard to find the source of your short if the wire is visible, because the wire's obviously getting hot. Okay. Looks like we do have some heat kind of at the middle of the board here. Hard to tell which side of the board that's on because it's not a lot of heat. So what I'm seeing is that somewhere in this area or in this area, we're getting a little bit of heat. So, comparing this to things that I've seen before, oh, I should also point out that, okay, so the reason why I wanted to make it a point to talk about this chip getting hot and remove it and then inject voltage is because part of the I kind of mentioned how this chip ties battery to VCC main, and it kind of does internally the same job that transistor in that the MOSFET in iPhones does, where it ties battery main to VCC main, and if you have a voltage on VCC main, you inject voltage through battery, the MOSFET gets hot. In the same way, it was this chip that was getting hot, even though that chip is not our source of the short. So I just want to make sure that that is clear. But now what we're looking for is a short on main, and I have seen it before related to the display boost driver, which is right around in this area. I'm not exactly sure where it's at on a Note 8, but I know it's underneath this shield and towards the bottom end. Let's just see if ZXW can give us any information on what is on main that's on this end of the board. And we'll see if narrow down our search. So, bear with me a moment while I get ZXW opened up here. Okay. So the layout is a little bit different here. The layout of the charging area there's a little bit different, but here is what's on main. So we have looks like we have a couple of caps here that are on main. Or are those coils? Looks like those are coils. Okay, so we have like a coil here that's on main, and it could be on this side of the coil something shorted. And then on the flip side of the board, we have this looks like it's going to be our display boost chip. And we have quite a few things on main, caps on main around here. So I think this probably is the area that we want to focus on. So we're going to need to remove this big shield. Now this can be dangerous. So I just want to make sure that I point out that you definitely should not just get in here with hot air and try to remove this. What you should do is there's always going to be a little cut in it, which you can find with just a little pressure like this. Find that cut in the shield, peel the sticker off a little bit, and that gives you a way to kind of get a hold of it with like some side cutters or something to start just brute force peeling this off, peeling the shield off. And that, in cases of data recovery, that's fine because you're never going to stick that shield back on. Since this is for the sake of this device, I'm going to go ahead and try to remove this shield in such a way that I can put it back on afterwards. So for that, I'm going to use some lower temperature alloy to get these solder joints a little more melted, a little more meltable, melt them at lower temperature. All right, come on, tweezers, get on there, pull that off. Okay, so the reason why this is a problem is because this shield is put on with the same alloy that's used to solder the components on. So it takes so much heat to get this shield off that you have to really heat the whole area enough that all the components, all the solder on components underneath the shield is also going to melt. And as you can see here at the edge of the PMIC, it is underfilled. So that's a big problem. We don't want that. So to avoid it, we are going to change the amount of temperature it takes to get this shield off. Alright, so just going along each one of these joints, taking my time to make sure that each joint gets melted and that the solder that I have on the tip of my iron, I've got kind of a bubble of solder there, making sure that that gets mixed in with the OEM solder really well. Some of these tight spots, it's really hard or impossible to get the solder mixed in there, so we're just going to have to, add as much as we can and hope for the best. It's going to be the same situation down here as well. I'm not going to be able to get that completely in there. All right, so I think that's probably as good as we're going to get for this shield right now. So we'll see if we can get that shield off. I'm going to make sure I turn my air down to a temperature that should be enough to melt this new alloy, but is definitely not enough to melt the solder of the underlying components. And now I'm going to get my bent tweezers to just kind of try and put some pressure on this shield to lift it up the end of it while I heat it. All right, we're getting it. Looks like we did not get enough into that joint right there, so I'm going to just hit that again real quick. There we go. Yeah, all right. Now I can just wiggle back and forth to break that last joint. There we go. Now, with minimal straightening on this shield, I'll be able to get it back on there. And now we're into our area that may be the source of the short. So I've seen it be a couple of things. This is our display boost chip. kind of like the chestnut for this device. And then there's a few caps around it arranged differently than what our ZXW showed. But, you know, all of the players are still there. So, you know, even though they're in different positions, there's still going to be the same number of caps that are on main, and it could be any of those. So we'll go back now to injecting voltage. And go back to the thermal camera and see if something gets hot. See if I made a good choice in taking that shield off and exploring this area before going for the other side of the board. Okay. So it looks like it might be the other side of the board. That's just classic Mark luck right there. So it looks like it's getting hot like in this area, but the two ends of this cap were clearly visible, so it's like it's the board that's heating up. So yeah, it's going to be something under this shield, which I have no issues with just yanking this off. So yeah, that whole process of removing that shield was essentially pointless, except you know, to be instructive for you guys watching on how to approach that shield, which I do think that's important. All right. There we go. Now I don't worry about you know, ripping up a few chunks of ground like that. It's really not going to hurt anything. So you know that somebody might look at that and be like, "Oh, that's bad," but yeah, really, no, it doesn't matter. All right, let's get power back into this and maybe finally find our short. Okay, so from this side, it's also looking like the short is coming from the other side of the board. So I suppose it could just be that end cap. Normally the ends of the cap will not show in a cooler temperature. The whole thing will just be white hot, but it looks like it may just be that cap. So let's see, is that cap on main? Is my multimeter turned on? All right, that cap is on main, so let's knock him off. All right. Do we still have a short? No, we don't. So we'll confirm that by connecting power and see, is this still consuming? Nope. We're chilling right around where we should be before prompting to boot. So now I will prompt to boot. If I can remember which pin it is, I think it's this center one to ground. Yes, yes it is. All right. Oh, maybe not. Maybe I gotta hold it for a little longer. Maybe it's a different pin. Oh. Oh man. Where's my head? I'm trying to prompt it to boot while I just have voltage injected into main, because that totally makes sense. Also, I'm trying to prompt it to boot while I don't have my charging IC on. And I know from experience that in this phone, I do need that chip to be present in order for it to boot. And I was planning on saving that same chip and putting it back on because it truly wasn't a problem. It wasn't, the source of our short. And now it seems that I've misplaced it. All right, so we'll get this off. We'll give one more quick look around the station, see if I can find where I set that chip. And if not, we'll chuck a new one on there. Let's see, not stuck to my arm. Didn't fall down here. Not finding it. All right, we'll just stick a new one on. Not a problem. Just going back over these pads with some leaded solder. All right, let's stick a new SM5720 on here. My orientation was like this. Now I'm going to have to turn my air back up, but not too high. We could use a little more flux in there too. Oh boy, that was a big shift. I did not have that lined up very good, and I do not believe that chip is going to be okay on there. No. We're going to save that chip to reball later. We're going to grab a new one. Man, this is this video is a mess. I'm glad I'm not streaming. That would throw me way off. See, it's things like this, which is why I don't stream as often, because like, I don't know, for some reason I'm fine with just making these dumb little, not even that important mistakes while I'm recording, and I don't feel the need to go in and edit anything out. But when I'm streaming, like, I don't know, I start to get really nervous, even though there's like 5 people that are watching and nobody really cares. It's just stage fright. I've always been like that.
Okay, so this looks much more properly lined up. I think it could use a little more flux, though. All right, that is good. Now we'll just make sure that that chip is stuck on there. Good, good. Now we'll flip over and look for any signs that I got the underfilled PMIC too hot, and there are no signs of that, so we are good. All right, so now we've got our charging chip back on. We are going to connect power to the battery. And say it is not consuming a bunch of current. So we will prompt to boot. And that looks like it's booting to me. So now we can get the parts. All we really care about right now, I just want battery, power button, screen connected so I can see, does this thing turn on? Oh yeah, of course battery's going to be dead because it's been sitting for a long time with a short on main. Okay. And there we go. We have image, and we will likely have this thing booted all the way up. Maybe? Is it going to boot loop? Well, I know sometimes they'll do this when I'm booting from DC power supply, but then when I boot from battery, they don't. So let me grab a good battery. Go. Let's see if that was just battery. There we go. So yeah, it looks like this is going to boot now. I should stop saying that because that's like the cue for it to start boot looping. Yep, there we go. Working touch, boots up on a battery. So, all right, we got this one solved. That was harder than it needed to be, but still pretty easy. I'm going to clean up the pads around where the shield was removed, take off all of that lower temperature alloy, straighten this shield out, solder the shield back on, and this will be just as good as it was to begin with. It'll just be missing that little cap there. Nobody will ever know. So thanks for watching.